Finally, it's a how much do you know about factoring? You know, equivalent or not equivalent. You know, the first thing, it should be easy enough to look at. You've got a 2x squared, and your last thing is a minus 3. That's pretty straightforward. This guy, however, is made up of two other things. The outer is your minus 2x. The inner is your plus 3x. That is a negative 2x and a positive 3x. That gives you a positive 1x. These are not equivalent in the proof. I wouldn't say that's pudding, but I'm basically showing the foiling technique. Now, can you factor that? Sure. If you want to go through the factoring process, by all means. Down here, this is a definition. These are conjugates because they have two numbers that are the same with different sign in the middle. Multiplying two conjugates will give you the difference in two perfect squares. If you factor this, recognizing that these are both perfect squares, you've got your 5x comes from here, becomes both of those, and your 4 becomes a plus 2 and a minus 2. That matches there, even though they're flip-flopped. These are equivalent, and they did that by factoring. Okay, show me your work. Show me that it works. Oh, dear goodness. Could this be the same? Well, if we distribute the 6, I've got a 6x squared minus 12x plus 6 if I've distributed. If I take out a 2 and a 3, that's another way of doing it. But that's a 6x squared. The outer is a minus 6x. The inner is another minus 6x. And lastly, it is a plus 6. These guys come together to become a minus 12x. That checks out. These are equivalent, and the proof right over there, yon puddin'.